Today we will see the convolutional codes Viterbi algorithm. See, earlier we have seen that how to generate a convolutional code, a code word. Now, this code word, how to represent in a code tree and trellis diagram, and from that, how to decode the code word, the convolutional code word into message word using Viterbi algorithm. So, if at all in the channel coding, what one of the convolutional code we discussed apart from the linear block codes and all. So in this case, the convolutional code decoding process is Viterbi algorithm. Initially, we'll see how to generate a convolutional code in brief. So that is what in the other video that convolutional code, how to generate convolutional code, we explained. Okay. In this case, the convolutional code, the two-stage shift register is there. For example, M stage shift register, M equal to 2. The flip-flops, two flip-flops are there. The constraint length M plus 1. Okay. And M stage shift register, which is taken. The nodes S0, S1, S2 taken, and there are two outputs. There are two modulo outputs. For every 1 bit at the input, it generates two code outputs. Okay. So the sequence which is given, the message bit, sequence is given sequentially in this case. In convolutional code, the message bits are given sequentially. So for every 1 bit, so outputs are generated from path 1 and path 2. 2 bits are generated for every 1 bit of message. We can consider the generator polynomial to generate the code word gi of d for every ith path 1 and path 2, I equal to 1 and I equal to 2. So this is what polynomial g ith of G0, G1, G2, G3, etc. The coefficients 0, 0, G1, G2 are taken the combinations of S0, S1, S2, etc. So if at all the combination S0, S1, S2 taken, combination is the impulse response 1, 1, 1. 1, 1, 1. So the polynomial can be written 1 plus d square as the d parameter. For every one shift, the power of d. Okay. And next path is the combination S0, S2 taken. So 1, 0, 1 combination. 1, 0, 1 combination. So the polynomial can be written 1 plus d square. D is 0. So this is what the polynomial. And message polynomial, if at all you take for 10011 message bits, so this is the sequence which is taken for five bits, L equal to 5 bits. So we can write it as message polynomial 1 plus d square plus d cube plus d power 4. So this is what message polynomial d plus d square 0. And by multiplying message polynomial and the generator polynomial, the code output 1 is getting. So multiplying this, we are getting this code output. And because of modulo additions, d plus dg equal to 0, d square plus d square equal to 0, like that. After simplifying, you get this code word. By writing this code word from this polynomial 1 plus d square plus d cube plus d power 6. So this is 1, d square 1, d cube 1, d power 4, d power 5, 0, 0. So this is what 1 plus d square plus d cube plus d power 4, d power 5, d power 6. So this is what output, code output. Second code output for path 2, multiplying message and generator polynomial. This is what code output. And 1 d plus d equal to 0. D square, that is 1, d cube, d power 4, d power 5, d power 6. So 1, 1, 1, 1, 1. So this is code output. And by combining these two outputs, C1, C2, so the multiplexing, this is the code output, convolutional code output is the combination of C1, C2. C1, C2 of every one bit. First bit, second bit, third bit, fourth bit, like that. Okay, 1 1 1 0 1 1 1 1 0 1 0 1 1 1. Okay, there are 14 bits because of 5 bits. So that is the code length is n into L plus m bits code length. So there are two outputs, 2 into 5 bits message, 2 stage shift register, 2 into 7, 14 bits. So if message sequence is long, we can generate the code output accordingly. So this is also another procedure to get the code output. C1, C2 can be generated by the combination of S0, S1, S2 of G1 and G2. So the message is given 100011 here, okay, and by shifting every bit after initializing initially 000 is taken as 0 S1 S2 nodes. So for every one bit, the combination of S0 S1 S2, the modulo additions can be taken 1 and 1 plus 0 plus 0 1 1 plus 0 1, like that. For second bit combination, by shifting this combination 0 1 0 1 0 plus 0 0. Likewise, for all the message bits, the code output is generated, and thereafter 2 more shifts are required to reach first bit, that last bit S0 to S2. So this is the again one more shift, and this is one more shift. The code output is 0 1 0 1 1. So this is the code output, and this code output in this 5-bit example, code output 14 bits are generated. Okay, this can be represented in a code tree or Tetris diagram. Okay, and in this case, first bit considered 1, the output is 1 1. If first bit is 0, output is 0 0. If second bit is 0, when first bit 1, so first code output 1 1, second code output 1 0. First bit 1 and second bit also 1. Then you have to generate the code output here accordingly. See, for every combination, first bit either 1 or 0, you will get the code output. Second bit either 1 or 0, you will get the code output. Likewise. So for all the combinations of message sequences 1 0 0 1 1, like that, the code outputs are generated, and these code outputs can be plotted, drawn in a code tree. So that code tree is considered in this code tree is considered by expanding. Whenever input is given 0, the branch, this is split into drawn upward, and whenever input 1 is given, that branch drawn downward. So first bit, if 0 is given, the code output can be drawn at the above of in this branch, upward branch. If first bit is 1 is given, the code output can be taken downward in this branch. The code output will be written. See, as in this example, message bit, first bit 1 is given, the code branch is downward, the code output 1 1 is written here. This is the 1 1. When first bit 1 is given and second bit from here, branch is split. When second bit is 0, this is upward. So this 1 0 is written at the upward. This is the 1 0. If second bit is given 1, we can write downward. This is the code output 0 1. When first bit 1, second bit also 1. This is the code output. So this will be the path. Now in this case, 1, 0. This will be the path. Okay. And third bit 0 is given. Here it is already here. Third bit 0. So again upward, the code output 1, 1 is written here. Okay. And fourth bit 1 is given downward. From here downward, the output sequence is 1, 1. So this is what 1, 1. Okay. Fifth bit 1 again downward, output is 0, 1. See, downward again 0, 1. So this is the path. 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 Now see here, the code output can be drawn like if we receive the code output, convolutional code output 1, 1, 1, 0, 1, 1, 1, 1, 0, 1. In this example, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1. This is downward 1 message input. This is upward message input 0. This is upward message input 0. This is downward message input 1. This is again downward message input 1. We can get it back. We can recover it back. The message message bit is 10011 as this. If we receive the code word correctly, if code word is not correct, what happens? So this path, just like that, some code output will be different. There will be an error. We can count the number of error. Instead of 1, 0, if at all we get 1, 1. So if at all we get 1, 1 here, we understand that there is a one bit error. If you go the remaining path, more or less in this entire path only 1 bit. If you go another path, there may be more number of errors. That is how we can choose this path. Anyway, this code tree, what happens if number of bits are more, message sequence is more number of bits, if not 5 bits, if at all 20 bits, 30 bits is a continuous sequence, this code tree becomes bulky, expanding top to bottom, and this code tree becomes bulky. So to avoid this bulkiness in this code tree, we can draw the same thing in trellis diagram. These are all this is not expanding top to bottom. It is just left to right. It is prolonging and extending. And there are four states. Let us take 0, 0, 0, 1 or A, B, C, D or 0, 1, 1, 0, 1, 1, 1, 0 like that. There are only, at every time, there are only 4 states for S0 and S1. Let us take S0 and S1. Whatever bit it is given, that you will get S0, S1 combination. So there are A, B, C, D, 4 levels, 4 combinations only. Now, so the code output is drawn if 0 input is 0 is given, solid line. If 0 is given, solid line. If binary input 1 is given, dash line. So this is the dash line. So for a given input message 1, 0, 0, 1, 1. Okay, like that. So if a first bit is 1, dash line, the code output is 1. So we got code output. What is that code output? 1, 1, 1, 0, 1, 1, 1, 1, 0, 1. 1, 1, 1, 0, 1, 1, 1, 1, 0, 1. Okay. So in trellis diagram, we represent for the first bit 1 dash line, the code output 1, it is written here. And second bit 0, 0 is given. So that is a solid line. The code output is 1, 0. 1, 0 is written here. And next bit, third bit 0 is given. Solid line 1, 1. So this is 1, 1. So this is 1, 1. Okay. So by the time S0, S1, 1, level state will be there. Okay. So that is how from this state 0, 0 to 0, 1. Whenever 1 is given and next bit 0 is given, so 0, 1 state given. It is drawn from 0, 0 state to 0, 1 state. So then next 1 is given, that reaches to 1, 1 state. So 0, 1 state to 1, 1 state. Okay. And next 0 is given. So 0, 1 state. 0, 1 state, it is going towards 0, 1 state. Okay. And likewise 0, 1, 0, 1 state. So that is how the output is drawn 1, 1, 1, 0, 1, 1, 1, 1, 1, 1. For every state, the code output is taken here. This is what trellis diagram representation. So in using this trellis diagram, how do we retrieve back the original message here in the Viterbi algorithm? As if you select for all the messages, the code output is drawn, let us assume, and code outputs are given here. And if the code output received, code output is received this way, okay, this way. So you can take the path 1, 1, 1, 0, 1, 1, 1, 1, okay, and 0, 1, 0, 1. So like that. So this one, this one, this one, okay, 1, 1, 0, 1, okay, like that. So these are two more shifts. So you can extend here likewise. If you take this path, what happens? This is a solid line, dashed line, solid line, dashed line, dashed line. So 1, 0, 0, 1, 1. So like that 1, 0, 0, 1, 1. That way, if received word is wrong, if at all we don't know, if at all you will get 0, 0 instead of 1, 0. There is 1 bit error. There is 1 bit error. Then 1, 1, 1, 0. This is 0, 1. So if there will be 1 bit error. In this path, 0 error, 0 error, 0 error, 0 error. So total 1 bit error only. If because this is 0, 0, if you go in another way, in another path, 0, 0 or whatever it is here, this path, the code, the errors are 1 bit error and the path is mismatch and errors go on increasing. So other than that survival path, which is shortest path, which is correct path, other paths are giving more errors. So the survival path, which is correct path, gives minimum number of errors. So if you select that by discarding all, this minimum path, that even 1 bit error that can be corrected instead of 0, 0, that can be taken as 1, 0 because this is 1, 0, that can be corrected 1, 0. So the error correction, we detect this error and we also correct that error. This is what happens in channel coding. So using Viterbi algorithm, this trellis diagram, which is very useful to avoid the bulkiness in representing the code word, other than like a code tree, and as well it gives the decoding process of getting message sequence from the trellis diagram by selecting the survival paths of which are having minimum number of errors. So this is what the procedure example, and this is what the each path, one error in this path. Let us take one more error, two errors, or in this error one error. 2 errors in this 1 plus 2, 3 errors, like that. In every path, the number of errors are increased. Only the shortest number of errors can be taken and go on increasing. And selecting minimum number of errors, select that path. From that solid line and dark line, we can get it back the message sequence. So that is what the decoding of convolutional code using Viterbi algorithm. So this is what the example of selecting minimum number of errors, that is called survival path. Thank you.